Yeah, welcome everybody. We are so excited to have our first OpenCV weekly webinar. And just to set the stage, this would be a weekly webinar where we will discuss different topics about computer vision and things that the OpenCV community would be interested in. And sometimes we will have tutorials, sometimes we will simply talk about topics like today. We are going to discuss the OpenCV AI Competition 2021. And as many of you know, that this was a competition that started back in January. And this competition is in two phases. In the first phase of the competition, we asked people to submit proposals if they had an Oak device, which is right here. This is OpenCV AI Kit for people who do not know. It is a spatial AI camera which can do neural inference as well as depth estimation in real time. It has three cameras. The middle one is an RGB camera, and then we have a stereo pair. And we were surprised. We got about 1,400 submissions in all. And out of those, we picked more than 250 submissions. Initially, we thought that we were going to pick about 210 submissions, but it became so difficult for us to pick the right ones. It was so competitive. So today we are going to discuss, we will talk a little bit about Oak, what the device does, etc., some background about what the device is capable of, how it came into existence, something about the competition, and then we will showcase a few entries from the competition. Unfortunately, we cannot do justice to all the fantastic entries, so we just picked a few of them, a handful of them, to show the breadth as well as the creativity of the competitors. So with that, I would actually like to introduce our panelists. First on the list is Phil. Phil is the content manager at OpenCV. He has been organizing all sorts of events for us, taking care of the content. And if you remember the Kickstarter campaign for OpenCV AI Kit, he was the one leading the effort. So welcome, Phil.
Hi, everybody. Glad to be here.
And then we have Brandon. Brandon is the chief architect of Oak. He is also the CEO of Luxonis. And basically, Luxonis is the hardware partner who designed Oak. They did all the heavy lifting on designing and manufacturing Oak. And Brandon is, the CEO of Luxonis. Not only that, he was also, before this, he was part of Ubiquity, where he led a team that shipped millions of hardware products a year. So he has huge experience in this space, especially with manufacturing as well as delivering hardware products. And finally, we have Anna. Anna has been associated with OpenCV for the last 10 years. She is the CTO of OpenCV.ai, which is the for-profit arm of OpenCV. But even before that, Anna has been with OpenCV for more than 10 years. And she has been at Intel. She is an expert in edge AI, all the way from optimization to model training, etc. And she's probably one of the top 10 women in AI that you probably have not heard about, just because she likes to be in the background. But exceptional people here. So I would like to begin by Brandon, why don't you give us the backstory about Oak? How did you decide to, what motivated you to come up with this idea of Oak?
Sure. So I was relatively new to computer vision, but transitioning into computer vision and AI actually, because one of my—
Brandon, can I interrupt you for 1 second? Sorry.
Yeah.
So I would request people to stay till the end. We have some goodies that, some discounts, etc., that we will announce at the end of this webinar. Sorry to interrupt. Yes.
You like saving money, stick around.
Stick around.
Yeah. So I was actually relatively new to computer vision AI, background in electrical engineering. One of my mentors had actually left to pursue AI full-time, and I eventually left as well. And I was trying to solve a problem, a life safety problem, I was actually planning on doing a different startup around embedded AI, and I was trying to convince all my friends to leave their jobs and join me in that startup. And all the conversations kept getting interrupted with like, can you hold on a second? Did you hear what happened to so and so? And that just kept happening. And it was our friends and colleagues and acquaintances, hackerspace founders had been hit by distracted drivers while they were riding their bikes to and from work. And so that seemed like a mission worth pursuing. I was already working in embedded AI and CV. And so I was curious if I could build a device that could just warn you when someone's driving distracted behind you, like a smart bike light. And actually some of the phase 1 winners here I see have that exact same idea to use this device, which I'm really excited about. So I iterated on all sorts of different neural approaches and CV approaches that you could use for this: LiDAR, radar, sonar, disparity depth, 3D pose estimation of vehicles and trajectories, monocular depth, all sorts of things. And I finally down selected that the most likely to be productizable was a combination of disparity depth sensing, a bunch of computer vision stuff like platform motion estimation, and AI to know what things are, and then use the depth map, the edge of the depth map, to perceive where the car is and the trajectory. And this is trying to solve the problem of just that one distracted driver out of 1,000 drivers that pass you safely, just the one that's slightly distracted and veering towards you. And I had that happen to me, where they almost clipped the front of my wheel and then went up and over the curb back onto the road. And it's just a distracted person Instagramming and driving. And so I prototyped it using Intel RealSense and neural compute stick and the Raspberry Pi and a bunch of other stuff kind of kludged together on a milk crate. It actually worked pretty well, despite only running at 3 frames per second because of data path issues, because all like the depth and RGB and everything had to flow through the Pi before getting to neural compute and so forth. And simultaneously, the Myriad X had just came out. That's what the OpenCV AI Kit, Depth AI, is all based around. And it had everything that was in that prototype in this big milk crate in one chip. So it had depth processing, the equivalent of like 3 real senses in it, in hardware blocks for depth processing. It had dual core neural compute engine. It had 16 vector processors for general CV functions, and it had something like 26 dedicated CV processors for all sorts of common things like warp and dewarp and image transformations and all those sorts of things. And so it was the perfect chip to do this, but all this stuff is bleeding edge, right? These capabilities were science fiction like 5 years ago. And so no platform had been built that would allow me to just quickly productize. So either I just had to give up and do something else, but it seemed like a really good mission. So I figured, well, I'll see if we can build the platform. And so that's what the OpenCV AI Kit is. That's what Depth AI is, and this whole thing. And the idea behind it is you can buy one of these just like you can buy any other standard product and use it. But we want to allow folks to solve their problems. So it's all built around this system on module that's pretty small. So in a lot of cases, this is small enough that you can integrate it into your product. So the library that allows you to do all this spatial sensing, real-time AI, and 3D object localization and so forth, it all works just on this system on modules. So if you duct tape this to something to do your prototype, like to the back of your bike or the front of your bike or side of your bike, then you can go ahead and use this and integrate it directly into a light design or something like that. And it just requires choosing where you put this and then where you put the little camera modules that go with it. And then we have all sorts of reference designs that are open source. So I'll grab some of these here. Like this is one that has a Pi Compute Module 3 built in. They're open source in Altium. This is the precursor to the OAK-D, but effectively the same thing that's in there. And even the mechanical designs for OAK-D and OAK-1 are open source. So what this allows you to do is you can take this module. This one has an ESP32 built in for Bluetooth and Wi-Fi, which could be useful in the bike application. You can take the thing, prototype it, but then if you say, well, I actually want to customize this to my needs, you can do so. And that's one of the things that was missing previously too, is there were great cameras that you could buy, but you couldn't really fully customize those to your need if you wanted to build a product. And so that's what our mission is we want to allow folks in these huge range of industries to actually productize around this stuff, so that prototype with this, integrate this into your actual product.
Great. I also wanted to ask you, one of the things that people do not realize that these products have their strengths, right? There are specific strengths. There are few application areas where OAK-D will shine like nothing else, right? On the other hand, we also want to make sure that if there is an application where you want to use your phone is the right thing to use, then use your phone. So could you explain, the 5 things that OAK is really good at?
Yeah, for sure. And so the phone's a great example. So the toolkits that exist in an iPhone and the cameras that exist in iPhone, they have disparity depth for this reason. They have time of flight, and so do a lot of Android phones. And so when you're developing on an iPhone or Android, you have great tool sets for all this. But kind of who is left behind is this like embedded engineer who's trying to build a smart bike light. I actually considered like, well, should I just mount an iPhone back there? Because it's pretty good, but it doesn't have the range. So this gives you those iPhone and Android-like capabilities for neural processing and CV and disparity depth and so forth that are quite mature and quite good there and allow you to actually build that into a product. So the niche that we cover is exactly as you alluded. If you can just use an Android phone or an iPhone to solve your problem, do that. They're great. But there are all sorts of problems where you can't, if you're trying to build your own product, you can't put an iPhone in there realistically. Some factories are actually using iPhones now because they're so much better than a lot of the factory cameras that exist. And so that's proof, like if you can just use an iPhone or an Android, do it. So our niche is if you need to embed it into a product, kind of awkward. You know, if you need a product that's this big, it's kind of hard to fit an iPhone into that. You need to embed it into a product. If you need it to be performant, so handle 12 megapixel, 20 megapixel video, those sorts of things, high frame rate, mini neural models or CV functions. A good example is there's a lot of applications where you don't necessarily need performant. And OpenMV, for example, is a great solution there where you're running one neural model or one CV function instead of a whole slew to solve your problem. Then the third is spatial sensing. So just like iPhones and Androids, there's spatial capability. So this has the capability, like you mentioned, Satya, to do 2 separate cameras for disparity depth. We'll have models that actually support 4 cameras and time of flight eventually. And then it has 12 megapixel color. We have variants that support 20 megapixel, but the spatial aspect is what allows you to mimic this human-like perception, right? Like the reason I can grab this on my desk is I have some amount of intelligence, but I also have spatial sensing, which helps me to like real-time grasp and understand where surfaces are. And then of course AI. So that's a core portion of this. There's a dual core neural accelerator, neural inference accelerator in there, and that's kind of the secret sauce that differentiates the current era versus the previous era when it comes to spatial things. So if you had a spatial camera, it was all about just producing a map of a head or a room or something, because you couldn't really make some intelligence out of it otherwise. With AI, then you can know that that's a dog and that you want to follow it for some reason, or that that's a car and it's on your trajectory and that you should take some action to warn against that. So the fourth is AI, and then the fifth is CV, the computer vision function. So we have intelligence, human-like perception, but in our brains we have these like equivalent CV functions like platform motion estimation and feature tracking and so forth that aren't really necessarily an intelligence aspect, but just like accounting for a platform. So we don't notice when we bob up and down walking down the street, like we're actually bobbing up and down, but our brains have feature tracking as like a function that's built in and platform motion estimation. And so when you build some robotic system like the bike light and the thing's wobbling back and forth, you need that sort of motion estimation. So those are the 5 things: embedded, performance, spatial, AI, and CV. And so we were trying to solve a problem that required all 5 of those. The platform wasn't available, so we decided to build it. And that's where we really shine, and where folks say, well, I'm glad this exists because it's the only thing that can do all this.
So is it fair to say that platforms like Jetson, one of the reasons you chose MediaDex was because platforms like Jetson do not natively support let's say CV functions, edge detection, or let's say feature matching and things like that. But with MediaDex, it is built in, and stereo is also built in, right? Because we are using the stereo algorithms built into MediaDex. Is that a fair statement?
Yeah, and to be clear, the Jetson's a great product. So the Jetson's extremely flexible, and they took the approach, which is have a GPU, have a CPU, and so you have all this flexibility. But it just means it's going to be less performant for the same size or the same power. And so a lot of the things you can prototype very easily on the Jetson, but then the amount of power that it's going to take can preclude you from using it in these certain applications, or the size that it's going to take, because quite a bit larger if you're trying to integrate a Jetson module, for example. I have one powered on the side of my desk. So the Myriad kind of took this in-between approach where Jetson is extremely flexible. Say like an edge TPU is a dedicated AI accelerator. So the Jetson can do CV, it can do AI, it can do some new thing we've never heard of because it's a general architecture. There's hundreds of just pure AI accelerators, which then lack this flexibility in the future because they're dedicated to just the math that we know now. But we're going to invent new types of math for these neural networks. And the Myriad X is in between in that it has these dedicated AI accelerators. It also has more general GPU-like things, but VPU. So they're not good at video games, but they're great at processing the real world. And then it has these dedicated hardware functions. And that's the thesis, is like, if you're going to do disparity depth, if you implement hardware in the chip for that, it's going to take less power, it's going to be more performant, so forth. And so it's kind of this nice meld between the two, where it can be lower power, lower size, lower cost typically, and lower latency, because it has dedicated hardware and flexible hardware, kind of marrying those two together. And it was the only thing also that allowed it to be like pure embedded. So you can run systems like this one, for example, doesn't even have Linux on it. It is just the Myriad X and then an ESP32, which provides Wi-Fi interface. So this is what we call OAK-D Wi-Fi as well. It's actually a slightly different form factor for this. But that was a lot of the why, is all those together so it can be more performant for the power and the size. So then you can use it in these like pure embedded, and then specifically the capability to run without Linux can be really advantageous in a lot of situations.
Yeah, and one of the things that we were very passionate about, that we wanted to make sure, is that we just don't give a hardware to people, right? It's about community building. We also wanted to make sure that the software library is so easy to use that I like to say an 11-year-old can use it. So I have seen multiple 11 to 12-year-olds who have been able to get it out of the box and get it running. So that's one piece. And the other piece is that we also want to support it with courses and all tutorials, all kinds of things, so that we are building a community around it. It's not like, oh, take this hardware and figure it out, right? And that, that approach has rewarded us hugely. We have a community of about 10,000 people, I guess, till now, 6,500 from the Kickstarter campaign. And then there are other people who joined afterwards. So that's something, it's really, we are passionate about building the community. And that's also why we are doing this weekly webinar. Some of it would be dedicated to OAK-D, but, OpenCV in general, we will be doing these weekly webinars. So before we move on, I think I should invite Phil. The genesis of this competition was actually OpenCV Spatial AI Competition, which was in 2020. It was a much smaller competition. We had, in the first phase, we had received about 230 applications, and then 32 teams were selected, and finally 6 teams won the competition. But recently, today actually, just an hour back or so, we started receiving a lot of press coverage about the competition, the last competition. And Phil, if you could just tell people, where we have been featured, about the competition, and what this, what the finalist was about.
Yeah. So Jagadish created this incredible AI backpack using OAK-D. They were a grand prize winner of the competition last year. I posted the link in the chat. In the last couple of days, there's been a spate of press coverage. Yahoo Finance, Tech for Good, Investor Ideas, Mashable, Washington Post. There's actually more popping up in my feed, my Google feed thing right now as I'm talking. But it's a product that just simply wasn't possible, I think, without OAK-D, without that specifically targeting human visual-like perception. It wouldn't have been possible.
Yeah, and I also think that, the entries that we got in that competition, even though there were a small number of entries, it opened up Intel and Microsoft. It was so compelling. The stories that were coming out of that competition were so compelling that Intel and Microsoft wanted to do a bigger competition, right? It was actually their
Absolutely.
idea, to be honest, that they approached us and said that what if we put thousands or hundreds of Oak devices in the hands of people, and then we decided, okay, if you want to do that, let's make it a global competition. I mean, just to give you, I grew up in India. Anna lives in Russia, right? And we are from different parts of the world, and it was important that this be a global competition, right? And that's why we divided the world into 6 different regions. And with doing a single winner for everybody, it was not fair in some sense. People have different problems, and some of the problems that are very relevant to one region may be completely irrelevant for another region. So we decided that we'll have regional prizes and then also global prizes. And this but the response was still overwhelming. We got 1,400 entries, and it was a nightmare. Fortunately, Anna stepped in, and she has such good organizational skills. She stepped in and just got the entire team together. We had about, Anna, correct me if I'm wrong, we have about 20 people who were on this judging process. So I would let Anna speak about how the judging went, what was the process, what was the criteria, what were the criteria based on which we selected the winners, and also let's walk us through a few winning entries. These are not, I won't like to say that these are our favorite entries or anything. These are representative entries. There are 250 of these very good high quality entries, and I just don't want to I just want to make sure that people understand that these are just something we had to pick to showcase, right? So I would let Anna speak from here.
Yeah. So yeah, I would like to second Satya in saying that we were completely overwhelmed by the quality of the submissions. So most of the documents, like these were PDF documents for every submission out of 1,400 that we received. They were big, very descriptive, very informative PDF documents with a lot of information there. It was great, and it was hard because we had to read everything to be sure that we are completely objective about this. And we designed this process of review so that every paper gets a review from not one, but at least 2 different people. In many cases, we did 2 or even 3-stage process, which meant the following. So first, 2 randomly selected people out of our 20 people reviewer pool looked at the submission, and they marked it with their grade. Now, we selected like in every region out of the 6 regions that we had, we selected the top papers and reviewed them the second time. Everybody who was on this region team kind of sat down and reviewed everything to kind of provide a more, mature review for every paper to make sure that we do not miss any, hidden gem there. So our main criteria were the following. First, it had to use oak, right? We did receive several really nice applications that sadly didn't use oak there, right? So for example, it was a submission for a very interesting iOS application, but by the rules of the competition, we didn't have, any chance to admit them because this is the competition that is centered around oak. The second very important criteria that we had is it had to be feasible. Now, we are not completely against something that is, very, very aggressive thinking, right? And very, very creative thinking. But we need to be sure that the team understands the scope of the projects to be able to actually pull it off in the 3 months period that we have. And this kind of feasibility is a very good indicator of understanding how hard the project is. Now, it's great that our team, the team that we had on the review board, it's actually very, very experienced AI and deep learning people so that we could really trust their estimation of the feasibility of the project. Now, one of the other criteria that we had is that the idea is better be exciting, right? It better be something really helpful to other people, or maybe entertaining, right? Which is important, especially in these COVID times, but it has to be, exciting in some sense. Well, we did not really. So for some teams, we actually decided that it's a great idea, but Oak is not a great match for them. And for these teams, we reached out and suggested other types of hardware like OpenMV or like 3D scanning hardware that would be a better match for this project, because we believe like our mission here is to increase the engineering efficiency in the world, right? And it would definitely help to not kind of oversell Oak to everybody, but kind of use it specifically in the niches that Brendan highlighted. Now, we actually really much value technical explanations, but they don't. They were not necessarily necessary for winning. For some cases, even without having in-depth technical explanation. For example, if the idea is kind of clear and very precisely explained, we were able to accept the paper as a winner of the first phase, even if they didn't have a very in-depth technical explanation. So we had this review split into 6 regions, as I said, and we actually had to select 210 different submissions. So we had 2 different types of teams. One is a general team. Everybody can form a team. It needs to have from 1 to 4 people on the team, and this is it, right? People can actually be distributed in different countries, like they may have or may have not any like formal education or even experience in the artificial intelligence field. For example, in some cases, we got these very interesting combinations of non-AI and AI people on the team that actually provides a completely new perspective to some problem that we as AI people were actually not aware of. The other types of team was university team. So these team are represented by typically some university lab or just university, and they can have up to 10 people there. So typically university teams provided a bit more research-oriented projects, but nevertheless, most university teams provided a very strong submissions that were based on many years of this lab's research and publications. And again, thank you everybody for submitting such a great proposals. Okay, so we had to select 210 submissions, but as I said, I did not expect these high quality submissions. I'll be completely honest with you. I was like, it was really wonderful reading them and very inspiring. So we decided that we will push forward and we will select actually more. And we ended up selecting more than 250 proposals to be selected for the stage 2.
So Anna, there's this backstory, right? We were ready to release this, the results, and then we started looking at all the people we had rejected, and we had rejected some good ones because, they were all good. So you had to reject some good ones. And it was so heartbreaking that we decided that we'll take 7 more days and see how many we can, put in. And then Anna and Brandon, there was a 3rd round of review where I know it was really hard for both of you. You guys, but you were all committed, and it was, Brandon and your idea to just go for 1 more round of review so that we do justice. And what ended up happening is that we just added a whole bunch of other teams. There were 250 teams, 257 to be precise teams. So that's what the 7-day delay was. It was just very hard to, pick the winners. And we just wanted to make sure that we wanted to do as much as possible, from a budget point of view, however many we could accommodate, we wanted to do that. So that was the last minute delay. So Anna, would you like to go over some of the, maybe 6-7 examples of projects people have submitted?
Sure, but let me first go through the most common topics that we got, and these are actually very, very important topics. And I wanted to thank you, the OpenCV community, because they were submitting the proposals for these important topics for the community and for the people out there. Even though the technical implementation of these specific application is very hard to do. So probably one of the most popular topic was the devices for visually impaired or deaf people, so that these devices can help them, live a richer life, orienting in the space in case of like visually impaired people, or read the sign languages in so many different, so different countries, because sign languages are different in different countries. So thank you everybody for submitting, thank you the teams who submitted the applications on these topics. COVID actually affects everybody, and we got a lot of submissions about social distancing and mask monitoring. Was a very important topic. So because of COVID, people started training at home, and this is a very, very popular type of activity. We also got a lot of AI-based sports training submissions that help people, do their exercises better, exercise in a more regular way, or even compete with their friends while staying at home, self-isolated. So agriculture is also a very popular topic. People want to, automate the agriculture and also make sure that the agriculture process is done in a very efficient way that doesn't harm the environment, so that less pesticides are used and stuff like that. And the final topic that I wanted to highlight is general robotics. Now, I, as like an AI person, I'm really kind of a bit sad about the current state of development of robotics, because I would expect it 10 years back, that at this point we would already have robots everywhere, but we still don't. So I really, really hope that OAK will, help advance this field in some way. So the submissions that we got were about implementing SLAM, or simultaneous localization and mapping, implementing self-unmanned vehicles, for example, targeted at search and rescue and stuff like that. Okay, so now let me share my screen, and I want to highlight 6 papers, 6 submissions that I personally like, just to give you, the breadth of the submissions that we got. So these are 6 winning submissions. Okay, do you guys see my screen? Please let me know.
Yeah.
Sure do.
Okay, so the first one I'm going to highlight is about a musical instrument that is called theremin. Actually, let me just show you what it is by this YouTube video. Oh, sorry.
Good background music.
Yeah, I don't know what that background music is.
I just turned on, the YouTube, the YouTube, page for this. Okay. Okay, so this is the device that is played by not touching it, right? So you need to, there are 2, different sides of the devices, of this device that you need, and you need to use your hands. This is the picture that we got from the submission team, right? They kind of show how it works in a very descriptive way, I would say. They show that the player uses 2 hands to play this device, and it's pretty tricky in terms of the distance to the device and the gestures that one needs to make to actually extract the right tone from the theremin. So they suggest to use OGD to help people train their skills of playing theremin. So there is a screen that shows the next position for the hands and distance to the theremin, so that the next note is exactly what you need it to be. So this is the device to help people learn theremin. And there is a mode actually to not have a theremin at home, but to learn it using just OGD. Now, there are two submissions pretty similar from completely different countries in the world that we got on theremin. They both made it to the second phase. So I'm really excited to see what these teams will be able to produce. So this is the team Clara. I want to highlight that one of these people here, Elisa Andrade, she is not from artificial intelligence, community. She's a musical professional. And the other member of the team, Jorge Chong, is artificial intelligence professional. And I believe by combining these skills, I really hope that these guys will be able to, create something absolutely new. So the second submission I wanted to highlight came from India. So there is a problem of trains in railway tracks hitting big and small animals, causing multiple negative effects, starting from the death of the animal and ending with the broken schedule of the track of the railway stations. So an easy solution, easy from the kind of technical point of view, would be to place the cameras along the track lines, detect animals using probably just commodity available models. For example, for this one, I would probably use some MS Coco trained model with elephant class and detect animals that cross the railway tracks. Understanding the depth really helps here because we can understand the distance to the animal, predict their trajectory and stuff like that. So this is actually one member team, which is exciting. So again, I'm really interested in what they will be able to pull off in this 3 months period. Another submission I wanted to highlight is a baby monitoring device that will help fight the syndrome of instant infant death that typically happens when the baby is sleeping in their crib, has their face looking at the pillow, right? And they don't have enough air to breathe, right? So that this camera helps detect these situations and send an alarm to the parents, for example, phone device or some alarm. Again, something very, very helpful, I believe, that will have a lot of different uses from all around the world. So this is the team. This is a 4-member team, general team. We will again see how they do. Okay, so now one more video. This is a prototype video from the team. They show their setup. They already have a proof of concept and they show it here on the video. Okay, so this is a device that helps train musical skills. In this case, in percussion devices, they have already existing prototype, and I'm excited by the fact that this is a father and son team. So this is basically the team. They have 2 people there. Because of the rules of the competition, the son is not 17. He's also only 17 years old, so they were not able to submit them for official as an official part of the team. But I'm thinking that for the next competition or even for this one, we may change the rules so this team can participate as a general team. And one more highlight is comes from Hawaii. This team wants to fight the problem of microplastic. They want to basically collect the data set and map the occurrences of microplastic on the beaches of Hawaii. To do that, they are actually going to use a drone. First, they are going to collect a data set of the images and then use Oak to automatically collect the data, detect and segment the microplastic on the beaches, and have the map of this of the distribution of microplastic in the beaches of Hawaii. This is a university team. They already have quite a research done in this direction, and I really hope that they will help solve this problem. One of the highlights here is that this is a localized problem, right? Exactly what Satya was mentioning, that this problem is very important for this region, not only this region, obviously, but it's really cool that University of Hawaii came up with this proposal. Okay, so these are the highlights that I wanted to mention. I would be really happy to answer any questions you guys have.
Yeah, so Phil, I think you had collected a list of questions from emails. Let's go over the email questions first, and then we will take the live questions. Right?
Yeah, we've got some live ones here, and we have a few from the email here. A couple of people, specifically Lorenzo, asked via email, and a couple of other people in the chat here have asked about the specifics of what people are, the reviewers are expecting for phase 2 of the competition. Satya, would you like to talk about sort of what what a good submission looks like for phase 2?
Yeah, so let me explain, what a great submission would look like, right? Which would be good for everybody. A great submission would have an exceptional video. We don't want, let's say, a 5-minute video or even less, something that demonstrates what they have done very easily. Because the last round, we have regional prizes, and then we also have this global grand prize. And for the global grand prize, we are actually asking top venture capital firms who will, we will do the judging for them, but they will be the final, they will finally pick who the winners are. And for them, it is very useful to have something in video format, right? These are kind of technical people, but they are not going to run your code to determine whether you will win or not, right? So very high quality video. Presentation is very important. I mean, it's a competition. Having good technical solution is good, but also put effort into the presentation. If you write papers, you know that how SIGGRAPH paper is written. It's about presentation as well. The second thing is that we will ask you to produce a report where you will explain all the technical details of what you have done. We would also, it would be great if you could also release your code, but it's not necessary. I mean, we will not judge you on that. It is just a good to have so that the community benefits. But we will not judge you whether the code is open source or closed source. So those are the 3 things, that we would want. But as far as participants are concerned, I also want to tell people that please document your journey, right? It's going to be very useful for you. You would look back and, these are memories. When you're my age, 41 or so, you will realize, oh, you cherish those memories. So document your journey through it. And it also helps us because we would like to see you guys publicize this thing. So yeah, that's it. You would have to, there would be a video demonstration, a written report, and if possible, code.
Great, thanks, Satya. There's also been a couple of questions here with regards to the competition timeline in terms of people getting access to the crash course and the Azure and Intel DevCloud access. Would you care to refresh people's memory on that?
Yeah, so Intel DevCloud and So we are waiting for everybody to get their oaks, which should happen by April 1st. So by April 1st, I think we should have all these things lined up, and we will send you access to Microsoft Azure as well as Intel Dev Cloud. We are also talking to a few of our partners who can throw in some extra goodies so that it may help with some free credits for their software, which you may use to train, etc. So yeah, April 1st.
Great. We have a more general question about OAK-D. I think, Brandon, you're already typing an answer to this if you want to answer live about the differences between OAK-D and RealSense. We've seen a couple of these, and it would be great to hear your take on that.
Yeah, so that's probably like the number one confusion on this sort of device, because it's the first and only that does this so far. So traditionally, even since the 80s, you have like depth cameras. You're like, what does a depth camera do? Well, it maps the world, right? Like it's useful for producing where things are, for doing localization and producing maps of a head, stuff like that. And then you have AI processors like these that you put in like a little mini PCIe, or I don't have a full graphics card, but you got full graphics cards, you have edge TPUs and so forth. And so the most common thing when folks first look at this is to think, it's just human. What does this fit into the buckets that I already know, right? And one is it's a depth camera, and the other is an AI processor. And so when folks look at this as an AI processor, well, that's a pretty dumb looking AI processor. What PCI slot does that go into? And then they look at it as a depth camera, and they're like, well, there's like 18 good depth cameras, and there's great like depth scanning cameras. Like, why'd you make another one, right? Like, we're good. And this is kind of its own new type of device, which is human-like perception in a tightly integrated product. So to one of the other questions of like, well, when I'm integrating, say, a depth camera and this AI processor together, I have to do all this glue code, and then the CPU gets overloaded with doing all that together when, I just want to know, where the rotten tomato is, right, in real time, or the rotten apple, right? Like, I don't want to have to all that glue code. And so what this does, both this product and then the system on module, is it does all that for you. So it's a depth camera, it's a CV processing camera, and it's an AI processor and AI camera all tightly integrated. So you can just say, here, I have a 2D object detector for apples that should be picked, and this will just spit out the 3D location of that apple for you. So that's part of the confusion is, well, how is this different from a RealSense? It's kind of like you took a RealSense, took an AI processor, took a CV processor, and some general processors, and made a baby out of all of those things. So like a Jetson Nano, a RealSense, and then some like vector processors, and you squished them all together into one chip. And this was David Maloney's mission, the chip that's on the system on modules, like whole life mission, is that you could put all those things together to have human-like perception on one little thing. So that's a big difference. RealSense could be used for mapping, or could be used with other AI processors and so forth. This is all of that crammed together.
Yeah, that tight coupling, I think, is really the power there. You theoretically could get all of these parts, but not that tightly integrated, not that.
And that's what I did initially, right? I bought a RealSense, I bought an AI processor, I bought a Raspberry Pi, and when you tie that all together, the Pi ends up so overwhelmed that you only get like 3 frames a second when you're trying to do all those things and the CV functions. And then you can have this thing do all of those at 30 frames a second. And you can sell the Pi if you want, but now your Pi can do all your business logic, like showing a display or showing some great graphics or whatever, or you can run it without a Pi.
Yeah, thanks, Brandon. I think this one might also be up your alley too. There's a few people have asked about OAK-D PoE and OAK-D Wi-Fi. I know there's been some slight delays there, but it seems like stuff's actually like picking up there.
It's a mess. It's a mess. So, Ford and Samsung and all these folks are having to like shut down production of things. And so like, on a weekly, parts that were supposed to arrive last week were like, what happened? And they're like, well, it was supposed to deliver in February, but now it's looking like July 2022, right? And so then we say, okay, let's redesign this for some part that we have, and then there's some unknown delay because we have to redesign, resubmit, reorder parts that then have some lead time. So we're going to do a Kickstarter update today on OAK-D Wi-Fi and PoE and so forth, but we're looking like probably June from all these like continual like redesign cycles. And mind you, these are with parts that we ordered in September and October.
Yeah, it
So
seems like a lot of those parts went from being long lead to almost impossible lead.
yeah, yeah. I mean, go ahead, Satya.
Brandon, quick question.
Yeah.
Do people have the option of
Yeah.
using OAK-D instead? If they want, they don't want to wait for that long of a time.
Yes.
Do they have the option of converting their
Yep.
OAK PoE version to OAK-D? Yeah.
Mine's all fingerprinted, but yeah, you can just switch back. So we've actually emailed directly, but I think I'm bad at email, so I got spam blocked a lot to say, if you don't want to wait because these are being delayed. So all the OAK-D production, we'd ordered that stuff in June or July, and so that was before this whole semiconductor crisis. And so all those finished. We have stock of them, so if folks want them now, we can. But the OAK-D PoE, Wi-Fi, and OAK-1 PoE all were like that September when the international shipping crisis and then the international chip crisis happened. And so literally we've gotten things back that what happened is these big companies that need supply have not only bought all of the supply, but then they've bought all future supply until middle of 2022. And so if we wait for these parts, so then we just have to redesign. But anyways, one of the other questions was along those lines, are you making an industrial? So this is the PoE. So all the designs that are done and have been in production since January. But it's just, if there's one key component, you just show up and the thing doesn't work, or you have to redesign around that key component that now is at delivery time of 2022. So someone called this a macro hurricane in the parts supply, and I think that was a good name. It was Sequoia, actually. Sequoia called this a macro hurricane.
Right.
They're going to be one of the judges. So these are IP67 rated, and they're silver, so you can put them out on some farm equipment, and they're not going to get a bunch of sun load and heat up. So IP67, so they're water sealed, and you can dump them to like
Perfect
a meter
for
or
next
whatever.
year's Burning Man.
OAK-D PoE and OAK-1 PoE, and so all of these are in production, but we're kind of at the whims of this macro hurricane right now. So if anyone wants to switch back to standard OAK-D, those ship right away. So feel free to reach out
what
to us. What
support email address should they hit up for that, Brandon?
I think store at OpenCV.ai. I think would be best there, and then the whole team can triage from there.
Sounds good.
Phil, I have one other thing that I wanted to bring up
Yeah, go ahead.
in case we are running out of time. So I wanted to bring up modelplace.ai. This is for all OAK users. And Anna, could you just explain quickly about modelplace.ai in case people have not heard about it? It is in beta right now. We have not done a public release, but for people who are interested on this webinar, we will give you access. Anna, take over.
Sure, and I think we probably need to dedicate a special, webinar to modelplace.ai. But just to give you an idea, so we created a marketplace for artificial intelligence models. And we have 20 models there that natively support OAK so that you can download, run it on your OAK. This will be super simple. We test it nightly. So one of the key features that we wanted to solve using the ModelPlace is the ability to easily test the model on your custom images so that you can just drag and drop your image that you want your model to work on, drag and drop it to the browser window. It will go all the way to our cloud and return with the visualized results. So you can easily understand whether it works or doesn't work for you. We will give you all an early access to that, and please stay tuned for the bigger news on the model marketplace.
And if you have any questions about this, follow-up questions, you can send it to newsletter@opencv.org for all questions related to this webinar. And Phil, are there more questions that need handling? After that,
there's a few.
Okay.
If we've got what, 5 minutes left or so?
We got 5 minutes, but we also want to announce the goodies that we promised at the beginning.
Yeah, I think most of these we can answer offline or in a follow-up. Let's go ahead and get to the goodies.
Okay. Well,
give me 30 seconds. So guys, if you are winners of the competition, please send us all your questions our way. We are going to have newsletters specifically for you, and we will be able to answer your questions there. Thanks.
That's great. And also, there are a few, believe it or not, there are a few teams who have actually not given us the address. They have not redeemed their coupons for for OAK-Ds. If you're one of those teams, please send that information over so that we can send you the OAK devices. Other than that, I think there are about 19 shipments which are still stuck in customs. We are waiting, we are working with them to the best of our ability. We have sent them all the documents. We are, even chasing them down in Twitter, trying to see if we can work with these government organizations to release the OAK devices. Okay, so now comes I'm going to ask you a question. So there are two classes of goodies. I'm going to ask you a question about OAKs. If you get it right, the first person who gets it right in the chat, and Phil, it will be based on Phil's screen, right? Whoever gets it right on Phil's screen will get an OAK 1. Keep in mind, it's not OAK D, it is the smaller brother of OAK D. It is OAK 1. So the question is, what is the processing power of an OAK device in trillions? Okay, we already got an answer. It is 4 TOPS, I guess. I don't know. Phil, we said that.
I'm taking a screenshot right now for proof.
Okay.
On my screen, it's Andy Gillen.
Yeah, I
yes.
saw the same.
I saw the same.
That was fast.
All right.
Question before it was asked.
Okay, great.
Inferred
So 4 TOPS is the answer. So that was goodie number 1. But for everybody else, don't be disappointed if you, especially people who did not participate in the competition or did not make it to the competition, we have discounts on OAK devices. We have 20 devices on sale. So I will give out the coupon code right now. You can go to store.opencv.ai and these 20 devices, the coupon code is valid only for the first 20 people.
Act
and
quick.
The coupon code is RELU, RELU 30. Let me repeat it, RELU 30, you will get 30% discount. And this discount code also works on OpenCV courses. So opencv.org/courses. Again, there are 20 discount codes for OAK-D as well as the courses. And we will also add, if you take the courses, you get to jump the wait line. Just email us that you want to get the course. We will enroll you immediately. All right, so that pretty much concludes the webinar. I'm so glad, above 200 people, most of the time there were about 250 people on this webinar, but even now there are 232 people. So thank you so much for showing up. We will do more of these. We want to, benefit the community, and also these live discussions are really useful because we get in touch with the community. So thank you guys. If you have any questions, drop us an email at newsletter@opencv.org. We will try to respond to all the questions.
Yes.
So that is it.
Some of the questions asked during the webinar here we didn't get to, but we will absolutely follow up with everybody privately about those. So don't worry, we'll get to your question, we promise.
That's great. And thanks, Phil. Thanks, Brandon. Thanks, Anna. It was great. Oh, by the way, I never mentioned my name. I'm Satya Mallick. Sorry about that. And I'm the CEO of OpenCV.org. So that is it. Thank you.
Thank you for joining us for the first OpenCV weekly webinar. Don't forget to hit that subscribe button and turn on notifications so you don't miss an episode. Big shout out to our sponsors at Microsoft and Intel. We'll see you next Thursday at 9 a.m.